Hey, geometry students, here we are. Welcome to lesson 6.5, our last one, 6.6, which is our last lesson from chapter 6 on trapezoids and kites. And so finally we meet the other two family members of the quadrilateral family, who are a little different from the parallelogram side of the family that we focused on so far. So we got two definitions, and they are these two new shapes along with one theorem. So let's jump right in. So the first shape is a kite. So what makes a kite? A kite is a quadrilateral with two pairs of consecutive angles. And actually, let me just fix that. I was writing that too quickly. Consecutive congruent sides. Okay, so a kite, let's go ahead and draw one. Looks kind of like a diamond. Okay, but what's going on with a kite is, first of all, is that you have two sets of congruent sides. So in other words, this side here is congruent to the side next to it. That's what consecutive means. And then the next side there is congruent with this side here. So it's got two sets of congruent sides. And we'll go over in the question some of its characteristics or superpowers. But the other thing you will note here is it has no parallel sides. So unlike the parallelogram and the shape we're about to talk about next, a kite is also kind of defined by the fact that it has no congruent side. I'm sorry, no parallel sides. Okay, just two sets of consecutive congruent sides. Alrighty, then we have a trapezoid. The trapezoid is a quadrilateral with, as we see here, one set of parallel sides. So it's kind of in between a kite, which has none, a parallelogram, which has two sets or two pairs of parallel sides. Trapezoid is if you have one, let's go draw it in black. If you have one set of parallel sides and then the other sides, whoops, I'll just still draw those in black. Okay, and then one set that isn't. So this is a trapezoid. Alrighty, and so one set of the sides are parallel, the others are not. Okay, and so a trapezoid, again, we'll go over its special characteristics in a minute. However, there is a special type of trapezoid that I'll go ahead and define here, and that is a trapezoid that, again, has one set of parallel sides. That's what makes it a trapezoid. But its sides, its non-parallel sides, are congruent to each other. And that is known as so in other words, these are congruent. These are parallel. This is known as an isosceles trapezoid. Make myself a lot of space there. Okay, isosceles trapezoid. The other thing I want to point out is a little bit of vocabulary, and that is the parallel sides of a trapezoid are known as the bases, and that the non-parallel sides of a trapezoid are known as the legs. So in an isosceles trapezoid, it has congruent legs and parallel base. Okay, so when we get into either the area or when we start talking about special characteristics, you're going to want to know that the legs are the non-parallel sides, the bases are the parallel sides. All right, and the last definition is a theorem that goes with trapezoids. That's the trapezoid midsegment theorem. And that is, I started it here, a midsegment along the legs of a trapezoid. So if we draw a trapezoid, that's what a midsegment is. We'll talk about what it means in just one second. If I got myself a nice little trapezoid, okay, and if I draw a midsegment, so a midsegment means it goes halfway from one leg, because it says along the legs of the trapezoid, and then I'm just estimating, that's roughly the middle. There's my midsegment, okay? And what we need to know about that, so what that is, these are congruent, and those are congruent because it's bisecting both sides, both legs, is that it is equal to 1/2 of the one base added to the other base. So in other words, if I know that if I know one base is x and the other is y, the midsegment is equal to, or actually maybe we'll just do it this way. we'll call this A and B, okay? AB, which is the midsegment, is equal to half of y plus x, okay? So it's basically the average, okay? So if I were to say, okay, so this is 2 and this is 6, then I would know that the midsegment is 4, okay, as an example. And so that's what the trapezoid midsegment theorem says, okay? So we got kites, trapezoids, and the theorems. Let's take a look. The questions are simply looking at the special characteristics or superpowers of each shape. First, number one is dealing with an isosceles trapezoid. So if we have an isosceles trapezoid, what do we know? Well, we know a number of things. One, we know that it has congruent diagonals. Okay, so an isosceles trapezoid, the diagonals are the same length. Okay, they are congruent to each other. They don't bisect, but they are congruent to each other. And actually, maybe that drawing is not super great. I'm going to erase that. It looks kind of like bisecting. So the diagonals are congruent. The base angles are congruent. So what that would mean, if I go ahead and label this A, B, C, and D, then I know that angle A is equal to angle B, and I know that angle C is congruent to angle D. Okay, so the base angles are congruent. And finally, check my notes, make sure I cover everything. And finally, adjacent leg angles are supplementary. Okay, so when you see that, because you basically have a same side interior situation here, angle A plus angle D equals 180. Same thing, angle B plus angle C equals 180. So in a trapezoid, all three of those things you can know to be true. Base angles are congruent, the adjacent leg angles are supplementary, and the diagonals, we could do it this way, AC is congruent to BD. Okay, so those are the superpowers of your isosceles trapezoid. Notice I'm saying isosceles trapezoid. We'll talk about it in class, but if you just have a regular trapezoid, only the third one is in fact true. All right, number two. And so what about with a kite? What are some special attributes that they'll torture you with various questions and exercises having to do with that beautiful kite or flying up in the sky? The first is that it has perpendicular diagonals. Okay, so the diagonals here, they are at a 90-degree angle. The other two are concerning angles, and that is that it's basically the angle that joins the non-congruent sides. That's kind of a mouthful, so I'm not going to write it, but that the angles A and C are congruent. Okay, so it's the sides. It's the two sides that are the angles that are in between the non-congruent sides. Those are the exact same angles. C and B are not congruent, but A and C are, because they're the angles that are between the non-congruent sides. Okay, so they are congruent. And the last one is that the diagonal bisects angle. Let me do it down here. Angle C and angle B. Okay, so in other words, this diagonal, the one that goes between the two congruent sides, it actually cuts each angle in half. So C and B are not equal to each other, but that medium line is cutting their angle perfectly into two equal sides. So bisects sides C and B. So in other words, angle, another way to say that is angle C Oh, whoops. I got two angle C's. Sorry about that. Getting ahead of myself. A, B, C. This should be angle D. And therefore, this right here, angle B and D are being bisected. Okay, there you go. That's the end of the video. And we'll be seeing you in class, and we will have lots of fun doing all of this geometry joy together. See you soon.